So, moving forward, like we said, we have a time to go over a couple problems today for your evaluation, which is tomorrow. And
there might be people I don't what time we get back from lunch.
okay,
Can I take the test like Thursday morning or Thursday?
yeah, that will work. So, all right. So,
You have an air compressor in here?
no, I do not have an air compressor in
Well,
here.
I figured you didn't, but
Well, I thought it might be able to hear it from outside because it sounded like it was a line or a tank that was leaking air, and that's what I had heard.
shed sounds.
So, with tomorrow's evaluation, it's over molar mass problems or percent composition, and maybe we're good with those because with the papers that you have in front of you, is there one that is more difficult than the other?
The one on top, number one.
Which one's more difficult? Okay. But that's not on tomorrow's evaluation. It is,
Molar mass.
as I said, molar mass and percent composition. So we've got some citric acid here and C6H8O7. Okay. So, all right. So C6. What did I say? H07. I know that. H8O7. Okay.
C6 or C7?
Okay. That's what I'm interpreting
I know. It's just
that says.
You said 6 and wrote down 7. That's why
Oh,
we're
okay.
double checking for you.
Oh, okay. C6, because this is where I need to get my magnifying glass. So, yes, that is 6 here for sure. Okay. And then, let's take a closer look at this.
Alright, the fidget spinner please.
Yes, ma'am.
That must just be a comma on there. C6H8O7. Okay. So with this, okay, what is our sample size of citric acid? How many grams do we have? How many? 20? Okay, so we've got 20 grams of citric acid. Okay, that's this compound here. Now you need to pick one of these three elements, and probably what we could do, front row, you do 6, middle row, you do 8, back row, you do 7. Okay, so front row, you do carbon, middle row, you do 8, back row, hydrogen, back row, you do oxygen. I'm looking at the subscripts rather than, yes. You are doing how much hydrogen is in citric acid if you have a 20-gram sample.
Oh, 20 grams?
So then front row, you're doing carbon. Okay. What's the percentage of carbon? Middle row, you're doing the percentage of hydrogen. And back row, you're doing the percentage of oxygen. I just thought of that all on my own on what we could do. So it's maybe a little unfair here. We have so many in the front,
Nah.
few in the middle, and just only a few more in the back.
It's aight.
So,
As long as everybody pays attention.
well, that's true. So we'll give you a few moments to work on that. Because here, it just gives you... Okay, so I think we've perhaps had enough time to work on these. So, for those of us who are still working on these, of course, we know a percent composition means that you just have that one extra added step. So the first thing you're going to do is when we add all these together, this is about 72, this is about 8, and of course, I don't know, 7 times 16, I don't know.
192.14.
That sounds a little high.
It's true. I got that too.
It's 192?
Yeah.
Okay. So 16 times 7 gives you 192. 8 times 1 gives you 8. 12 times 6 gives you 72. So then
Well,
when you...
not for oxygen. Like the whole thing together is 190.
Yeah, oxygen is
Okay. That's... All right. So oxygen, 7 times 16 gives you what?
112.
112. Okay. So then when you add all them together, it says you should get 192.13. Okay. So where does that number go in our second step? This is step 1.
The bottom.
So 192, whatever you came up with. The bottle says 0.13. That's what we're going to go with.
They put moles on
Then this gives you one what on top?
top. One mole. Citric acid.
You have a mole of citric acid.
They put mole of citric acid on the bottom.
Now, this next step here allows us to convert what we have. That's probably the 8th time we said, maybe more. What we have, which is this entire compound, for moles of citric acid. So which one of these would you like to do first?
Carbon.
Okay, so then what we have is citric acid. What we want is carbon.
Times it by
Okay.
6.
Then after step 3, we get to step 4. And whether you do this at the end or do it right away, you do have to put a 6 there. Of course, that number comes from this little subscript here because you do have 6 times the amount because of that subscript again. Now, we're on the home stretch. For every mole of carbon, okay, how many grams do you have?
12.01.
Okay, I guess I put an extra step on here that we didn't need to do. Okay, so then let's make sure our factors cancel out. These two do, these two do, and then these moles cancel out those. So we're just left with grams of carbon, and that's what we would want. So now, upon doing our last step here, what do we get for grams of carbon here? What do we get for grams of carbon, front row?
Like all together, what we get? Oh, 7.50 grams of carbon.
Okay, so 7.50 grams of carbon. Now, if we want to do the percent composition of that now,
Divide by what you start with. So 20.
okay, so, and it's going to happen. You don't think it's one of those things that can, but it will. When you say divide by what you started, is it this number or this one?
20.
We sure?
Almost.
Yes. So then, in that case, you divide that by 20, and then that gives you, what's your decimal?
0.38.
Okay, so it comes out to 0.38 something.
It actually just rounds up to 8.
And it's
Oh,
37.5.
okay. Okay, that would be 0.38, which means 38%. Oh, 38% of this is carbon. So then, next thing we do is, I guess we really don't have to totally reinvent the wheel here. What we could do is just say, do our hydrogen next, which we would presume this will all change. The atomic mass for citric acid will be the same. Now for every mole of hydrogen, how many of them do we have? Okay, and of course that 8 comes from here. And then, no, I almost put moles of hydrogen. Well, I guess we can do that. 1.01 grams of hydrogen. So then hydrogen goes down here. Are we going too fast for front row? Are we on the bus here?
Yes. Yes.
Okay, middle row and back row. Okay, well, we see this, we see hair moving, so Well, let's make sure we get to the right spot then. So then take 20 times 8.08 divided by 192, and that gives you approximately what?
0.84.
Okay, so 0.84. So then that gets divided by 20.
You get 4%.
You get 0.04, which means we've got 4% hydrogen. So technically, we don't have to do that last one because we could say that's 58, right? Somewhere thereabouts. Is that what you got?
Exactly 58.
Okay. But let's just look to see and just confirm our results here. So we've got 20 grams of citric acid. Then for every 192.13 grams of citric acid, you get a mole of citric acid. Then for every mole of citric acid, you get a mole of oxygen. But we go back to our formula. There's 7 of them there. Then for every mole of oxygen, you get 16 grams of oxygen. We multiply all those out, and we must get a little over 10, maybe 10 point something.
11.66.
Okay, so this gives you 11.66. That, of course, is in grams of oxygen. Divide that by 20, and then that's where your 0.58 comes from, and we change that to 58%. You add all them together,
Yeah, 100%.
there is your 100% sample. Okay, so this, you can show this mathematically how these all add up to 100%. All right, so this could be a molar mass problem, but if we did that, it would say how many grams of hydrogen are in 20 grams of citric acid. Then once you got 2.84, you would be done. But if it's saying what is the percent composition of hydrogen, then you have just this extra added step.
Can you say that what you just said again? Sorry, I just zoned out.
So like,
Okay.
you know, about percent composition.
So after answering a question, this is what your evaluation is over tomorrow. Okay? All right. So that closes the door on this for right now. Are we having problems on your papers that are in front of you? Yes.
Can I have another day to work on that,
Sure.
please?
Yep. And
Yeah.
then, is there anything you feel that's relevant on going over on that paper that you would like to ask that you think someone else could benefit from? Otherwise, you have 5, 10, 15, you have 19 minutes left. That time will or would be yours to utilize how you see fit. I don't want to say it gets more difficult. It does, okay? But so that appears to be where we are ending, or do we have something that you want to go
No, I
over?
was just gonna ask if I could staple this.
Oh, well, yeah.
No, you can't. No? That's gonna be not for the stapler? Thanks.
Yep. Okay, so that's all I have. We will catch up to you next
Oh, no,
time.
no, no.